Animating a plastic mesh with expressions. For this demonstration, I'm going to show how to use expressions to control a plastic mesh. The plastic mesh tool is used to allow the distortion of an image. The mesh can be hand-keyed, but what I'm going to demonstrate is an additional way of doing it using expressions to control the way that the mesh moves and the individual vertices themselves. The goal of the mesh in this case is to distort the square so that it looks as if it were hand-drawn from frame to frame. To do that, the plastic mesh tool was applied, and that creates a mesh column. And on that column, a skeleton is added in order to control the corner vertices and the sides. Now, this isn't a demonstration, a tutorial on how to use the plastic tool itself. This is only about how to control the animation of it using expressions. For more information on the plastic tool itself, please refer to other videos created by others online and the manual itself. Now, there are two things that are animated in this case, in this demonstration that I'm showing. The movement of the square left and right on the screen, that's being done by animating the mesh column itself. And that's hand-keyed. Looking over in timing, you can see the mesh, column 2. The X value is keyed using easing. And that was set manually, a keyframe at the start, a keyframe at the end, and a keyframe in the middle, so that it cycles back and forth. Rotation was also animated. Now, rotation is the first place where an expression is being used. Switching over to the column, I should say the spreadsheet view. Click on the column heading there for rotation, and we see the expression that's been set. Now, this is a function within the expressions called random, and it generates a random number between the range of -3 and +3. And this is referring to units of degrees. And so the square will rotate -3 degrees, which is counterclockwise, +3 degrees, which is clockwise, some value in between those two from frame to frame to give it that hand-drawn look. You know, hand-drawn is not going to be precise unless you're using snapping on a grid or something of that matter. So this simulates the little bit of rotation that there would be in a square hand-drawn from frame to frame. Now, the next place where expressions were used is on the skeleton itself. Now, a skeleton on the plastic mesh tool, although it has the same name as the skeleton built using the skeleton tool, it's actually controlling vertices on a mesh within one column versus the skeleton tool. The skeleton tool is controlling the relationships between different columns. A plastic tool, it's controlling the relationship between vertices on a mesh within one column. That's the difference. Even though they both use the name skeleton, they refer to a different context. Now, the skeletons on a mesh, it doesn't refer to things as bones, it refers as vertices, a vertex. So there's a root vertex, that's the solid-filled box. These other hollow boxes that branch out from there in this example are controlling the corners and the sides of this mesh. Once the bones are set up, there's a way to control the distance, and although I'm not doing it in this example, there's a way to control rotation as well. What rotation would do, let's say if I was on vertex 8 and I were to adjust its rotation, you would see it swing in an arc around its parent. is parented to root. So you would see that corner move a little bit this way, as I'm showing with the mouse. It could have been added to this example. It would add even more variability to make it look even more hand-drawn. But I didn't need to do that. At the size that this box is, that the square is, it seems to be hand-drawn well enough without making the corners rotate that way. What is animated is the distance. So if I click on one of those, you'll see the corresponding column turns yellow over here. And if I click now on that heading, I see the formula. So again, we're using the random function, and this time the range value varies from 0 to 5. So 0 means no movement from where that vertex was originally placed when the skeleton was set up. And a 5 means it's going to move outward from its parent, which is the root. And so this corner is going to randomly move out and then back based on each frame, based on the random function. And that's it. Now, you get this view when looking at the mesh column. Once a plastic mesh has been assigned, we see that in the effects room. This is the original drawing. This is the mesh assigned to it. You see the parenting relationship that's established here. And once that's been set up, all the animation is done on the mesh itself, and the drawing follows along. The mesh controls it. Just keep that in mind and take a look at the example. It will be uploaded, available for you to review it, and think about ways you may incorporate this into your own work. Thank you for watching this video, and keep an eye out for the next video.